Hello, and welcome back to the channel. I'm Farid, an electrical engineer and PLC programmer, and in today's video, I'll guide you step by step on how to use timers in a Siemens S7-300 PLC using ladder logic. A timer is a fundamental function in PLC programming, used to introduce a time delay between control operations. It plays a crucial role in industrial automation by allowing specific actions to occur after a predefined period. For example, starting a motor after a delay or turning off a device after a certain duration. By the end of this tutorial, we'll complete this project together easily, flashing an output using a timer with a desired time value. In traditional electrical control panels, these time-based operations are typically handled by physical timer relays. These are standalone devices that require wiring, manual configuration, and take up physical space inside the control panel. However, when using a programmable logic controller PLC, we can replace physical timers with software-based timers. All PLC models, including the Siemens S7-300, support several types of built-in timers. These timers are fully integrated into the PLC programming environment and are configured entirely through software. This reduces hardware complexity and significantly improves system flexibility. The S7-300 PLC supports 5 types of software timers. 1. Pulse timer. 2. Extended pulse timer. 3. On-delay timer. 4. Retentive on-delay timer. 5. Off-delay timer. In this video, we'll focus on the pulse timer and explain how it works step by step in ladder logic. What is a pulse timer? The pulse timer activates an output for a preset duration. When the start input becomes true, the timer output Q is activated immediately and stays on either until the preset time expires or the input turns off, whichever happens first. I've placed the pulse timer in network 1. Like other timers, this block includes several inputs and outputs. What makes timers different from each other is how they behave and how they are triggered. Let's go over the inputs and outputs one by one so you can understand exactly how the pulse timer works. Inputs. S. Start. Starts the timer. When this input is true, the timer begins counting. TV. Time value. Sets the desired delay time, entered in S5T format, more on that shortly. Example, S5T#5S represents 5 seconds. R. Reset. Immediately stops the timer and deactivates the output, even if the time hasn't finished. To restart the timer, the start input must be triggered again. Outputs. Q output becomes true as soon as the timer starts and remains true until the preset time elapses or the timer is reset. B. I output shows the remaining time as an integer. This can be stored in a memory word. BCD. Remaining time, BCD, shows the remaining time in BCD format, useful for displaying time on an HMI. At the top of the timer block, you assign a timer number like T0, T1, and etc. The number of available timers depends on the specific PLC CPU model. For example, some CPUs support up to 256 timers, while more advanced models can support up to 512 timers, offering greater scalability for larger automation projects. In this example, I've used T0. I'll connect the start input to a normally open contact with address I124.0. Then I'll connect the reset input to another normally open contact with address I124.1. Finally, I'll connect the output Q to a coil with address Q124.0, which will indicate the timer's active status. Setting the time value TV, S5T format. The S5T format is used to define time values in Siemens S7 PLCs. This format helps the PLC understand how long a timer should run. The general structure looks like this. S5T sharp, AH, BM, CS, DMS. Here's what each part means. Replace A with a number, then write H to show that it's in hours. Example, S5T2H means 2 hours. Replace B with the number, then write M to show that it's in minutes. Example, S5T15M means 15 minutes. Replace C with the number, then write S to show that it's in seconds. Example, S5T10S means 10 seconds. Replace D with the number, then write MS to show that it's in milliseconds. Example, S5T250MS means 250 milliseconds. Examples, S5T5S means 5 seconds. S5T2M30S means 2 minutes and 30 seconds. S5T1H15M means 1 hour and 15 minutes. The maximum time supported in S5T format is 2 hours, 46 minutes, and 30 seconds. One of the great features of Simatic Manager is that it allows you to simulate your PLC program without needing real hardware. This is extremely helpful for debugging your program or practicing, especially when you're learning PLC programming. To use the simulator, here's what I do. First, I open the simulation window from the toolbar. Then I select PLCSIM MPI as the connection type. Next, I insert the input and output variables. For example, the input at address I124.0 and the output at Q124.0. I also enable Always on Top from the View menu so that the simulation window stays visible while I work. Then, I switch to the OB1 window. Download the program to the simulator. Run the CPU, and go online. Now let's test the timer. When I activate input, I124.0, the timer output Q turns on immediately and stays on until the preset time expires. The timer counts down and shows the remaining time, and when the countdown finishes, the output automatically turns off. In the next test, I activate I124.0, but then deactivate it before the timer finishes. As you can see, the timer stops immediately and the output turns off. This shows that the pulse timer requires the start input to remain true for the full preset time. Finally, I test the reset input at I124.1. When I activate it before the time ends, the timer stops immediately and the output turns off. To restart the timer, I need to trigger the start input again. And that concludes the explanation of the pulse timer, including its inputs, outputs, and how to test it using the Simatic Manager simulator. Now let's create a small project to put what we've learned into practice. We're going to use 2 pulse timers to make a light flash continuously, turning on for a set time, then off, and repeating this cycle. I'll add another network and place the second pulse timer, assigned to T1. I'll configure its inputs in the same way as the first timer T0 in Network 1. To ensure that the 2 timers don't run at the same time, I'll use normally closed NC contacts. For T1's start input, I'll add a normally closed contact and link it to T0. Plaque after input, I124.0. For T0 start input, I'll insert a normally closed contact and link it to T1 right after the input I124.0. This setup ensures that only one timer runs at a time. As they alternate, the result is a flashing effect on the output. I've set the time value of both timers to 3 seconds, but you can adjust them based on your needs. For example, you could set the on time to 4 seconds and the off time to 6 seconds, or any other duration depending on your application. Let's test this program in the simulator. First, I'll download the program to the simulator. Then run the CPU and go online. Then, I activate the input at I124.0. Here's how it works. When you activate input I124.0, the first timer T0 starts. While T0 is running, its normally close contact blocks T1 from starting. Once T0 finishes, its normally close contact closes, allowing T1 to start. While T1 is active, it normally close contact blocks T0 from starting again. When T1 finishes, T0 is allowed to run again, and the cycle repeats as long as I124.0 stays on. Finally, I connected the output coil only to the Q output of T0. So, when T0 is active, the output is on. When T1 is active, the output is off. This gives us a simple flashing light controlled by 2 alternating timers. As soon as I do that, and as you can see, the output at Q124.0 starts flashing, it turns on for 3 seconds, then off for 3 seconds, repeating the cycle continuously. This confirms that the timer logic works correctly, and the flashing effect is achieved just as we expected. I hope you found this video helpful. If you enjoyed it, please like and share. Your support truly motivates me to keep creating valuable content. In the next video, we'll dive into the extended pulse timer and explore how it works step by step. Don't forget to subscribe so you never miss an update. If you have any questions or need help with your PLC projects, feel free to leave a comment. I'm always happy to help. Thanks for watching, and I'll see you in the next one.